Good morning, student. Myself, Dr. Govind Sharma, Assistant Professor Mathematics. Today, with our series of linear algebra, our topic is running linear transformation. Previous lecture, we discussed about the linear transformation, what is linear transformation, and their properties, how we identify this function is this mapping is linear transformation. So, the objective is the same for understand about the linear transformation properties of linear transformation. Now we go through the lecture of that. Just a recap. In previous lecture, we studied about linear transformation. Linear. So in linear transform, we take T mapping from V to W, and V to W mapping. This mapping is called linear transform if T x plus y. We can write as this, and second T alpha x we can write if T can be give us two results, then T will be linear transform. For example, we have take Tx is equal to Tx, so we take Txy to element becomes Tx plus y x plus y. This is called Ax plus Ay. We can write here Tx plus. So this is the linear transformation. First condition is satisfied. Now the second condition, T alpha x. T alpha x means T alpha x. And we can write here alpha ax, or this become alpha t. So this is the second condition also satisfied. So we can say each linear transform. Then after we find linear transformation, the concept is kernel of linear transformation. Kernel of linear transformation. Kernel of linear transformation. Kernel of linear transformation means let be linear transformation. So the kernel T, simply we can say that the collection of V where Tx is equal to 0 dash is the identity element of. Okay. So so till here we can we already read in previous lecture. Now how to find out the basis. So let T8, for example, let one example for basis we have already done, I think. Okay. So T define as A B C. A B C is the element of define as A plus 2B, A plus 2B, A plus 2B plus C and minus A plus 3B plus. This is a linear transform. Then find the basis of kernel. The solution. What is the solution? So if this is the kernel, T is the kernel. T is the kernel of T. What is the kernel of T? Is equal to 0, converting 0 element. Here A B C is equal to A plus 2B plus C minus A plus 3B plus is equal to 0. So we can write A plus 2B plus C minus A plus 3B plus is equal to 0. So A plus 2B plus C is equal to 0 minus A plus 3B plus C is equal to these two equations. So here we see that there are three variables and two equations. So we have one Li. So we take C is equal to K. We take P is equal to K. Then we take C is equal to K. We get A is equal to 3B plus K. by third. Now we put the value in 1. So 3b plus k plus 2b plus k is equal to 0. Implies 5b plus 2k is equal to 0. We can do it by we do a is equal to 0. Make some easier. If minus k, then we get k here. Hmm. C is equal to k. K kb plus 2 k should be equal to minus 2k upon 5. And a is equal to become minus 6k upon 5 plus k. So this is we found k by minus 8. So here we use this part and do so here the span kernel T minus k upon 5 minus 2k upon 5. So we can take out 1 by 5 of 1k. So this is become multiply 5 to minus k minus 2k 5 and minus 1 minus 2. This is the kernel basis of. So basis of kernel equal to minus 1 minus 2 5. Okay. Now we see that there are two linear equations and three variables. So one variable, so dimension range, we can say the solution of kernel T, dimension of T, range T we can say 2. and the kernel T dimension is 1 because one element, one variable simply give us 0, result give us 0. So the dimension of kernel T is equal to 1. This is called the nullity dimension of kernel with the set, or we can say the basis of null solution. Yeah, null space is called nullity. So nullity or nullity is there is only one element in the dimension of kernel T, so dimension nullity is 1. Of course, dimension range T plus dimension kernel of T, and this is nullity. This is called nullity. This is called RT means rank is equal to dimension of. So this is called this is called the rank nullity theorem also. Now we move to the another question. Now we move to another question. Now let now definition of range T, range of T. Range T. What is the range T? T let T u to v w be a linear transformation. The range of T the range of T is the set of all possible V in W such that Y is equal to T for some x of for some for some x So some x in V. The range of T can be written as the range of T can be written as range, okay, and T is obviously the range of T is subspace of very simple. We know that let here is a vector space V, here the vector space here some element we take A, B, C, like that. Here some element A dash, B dash, C dash. The mapping from here to is called T. Okay. Then Tx, x from if we take x from B, then Tx is the element found in W. So the set of image of x, Tx, the collection of Tx is always in W. So if we give the range, this is called the range of x. We give this name T. So y belongs to W is the subset of a subset of W. Why? Very simple. We can say x from here. Instead we take x and image of this found in here Tx. So all the x, y, z, cube, whichever element from taken from X, V, the image found in W and their collection, images collection, it make a set, and this set is the subset of W. So W is a subspace. So the subset or subset of W is also a subspace. So understand this theorem, definition, saying that T is linear. The range of T is that of all possible V. All possible V. That of all possible V such that V y is equal to T. जो भी इमेज रखता है W के अंदर उनका कलेक्शन is called the range of T. Okay? Range of range of T. Now I think this is clear. And this is the subset of W. This there should not be any confusion to understand this term how it is subset of W. Because we take X from V and the image of X is T is always found in TW. So range of T is the subset of W or subspace of T. Now we take a numerical problem to understand that define like a problem, define E E3 to E3 as T A B C is equal to A minus B plus C, A minus B plus 2A plus B minus C, 2A plus B minus C, and minus A minus 2B plus 2, minus A minus 2B plus 2C. Determine the rank and dimension. Determine the range. Range means अभी just I give you and dimension of okay. Now what is the mean of that? Here A, B, C are the element are taken from E3 first item and their image, okay, their image in E3 also in E3. So it can be take image as y1 y2 x, okay. First we start A is equal to A minus B plus C, 2A plus B minus C. We write in column form. We take this is equal to y1, this is equal to y2. Now this make a, now this is linear equation. So if they consistent, then it gives the solution. So we can write here as linear form. So we make augment matrix 1, y1. This make augment matrix. Now we apply to try to make echelon form of matrix. So we multiply R1, R3, R3 plus R1, R2, R2 minus 2. So this term, the this and this will make 0. So we get 1 minus 1, 1, y1 0 -1 +1 y2 minus 2r1 0 r1 minus, so this will become -3, and this term become -1 and y1 plus y. थोड़ा सा calculation, there may be some chance of mistake, so our solution may be different. One. Now we have to eliminate this part. So we do R3 R3 plus minus 3R2 1 minus 1 1 y1 0 minus 1 plus 1 y2 minus 2r, and this will be become 0 0 3 2 or here multiply by 3 6 minus 5 r1 plus 4r. This is minus, not plus, minus. So minus 4, and this will be done by, so it will become y1 plus minus 5 r1 is minus 3 y2, sorry, y1, यहाँ गलती से y2 and plus 1. Here also y1. I write here y1. Okay. Now now our this is our, so for the image we find y1 y2 is at this in the form of solution of linear transformation. Here one of them should be so this should be equal to 0 for a consistent. Here the system is consistent. So about this we can make 0. In this form also we cannot make 0 because these are not linear dependent. No one can be make 0. Okay, not possible to make 0. The writing on it should be 0, but it is not possible. Make some confusion here. Okay, no issue. So the image, so nullity is here because the rank of A is equal to the augment matrix. Rank of augment matrix. So we know that this will give us a solution, unique solution. So here nullity of T, no row becomes 0. So no vector give us the result is 0. So there is no vector. We can take x1, x2, x3, three column vector. No one give us 0 result equal to 0. So nullity is equal to 0. So range of T, or we can say dimension of T, is equal to dimension. Because kernel in dimension of kernel is 0 because no element, no vector give us a 0. So the dimension of T is equal to range of 3. This is our range. Okay, students. Now we come to the our part. I hope this is the calculation part for more interesting. So we continue with the numerical. Now we come to our skills. Which is the LT, EBC, this the basis of kernel is. So I already in this lecture I found the basis of kernel is 1 minus 2 minus 5. So A is the right option. Simply we put the image is equal to 0, Tx is equal to 0. So A plus B plus C is equal to 0, A minus 3 minus C is equal to 0. One of them is 0. So which is the LT? Which is the LT means LT, which is not LT, the LT. This, the LT. Nullity is 1, nullity is 2, 0 and A minus B. So nullity is equal to A because they make two equation with three variables. So one is the LT. We can correlate but not say that this is the already true. But we can correlate with the rank is equal to 2, make 2. So nullity is equal to 1. What is the rank nullity theorem? Rank is equal to order, rank plus nullity is equal to order. That's right, B is the right option. Rank plus nullity is equal to order. This is also Sylvester law. Which is the LT? LT is the linear transformation. Tx derivative operator from polynomial to polynomial. That is the right. Ax is equal to constant value is always constant, then it not give you 0 vector not give 0. and Tx is equal to Ax plus C not possible. So Tx is equal to derivative operator is polynomial is and so A option is the right, which is the LT. Derivative polynomial we have already discussed in previous question. Integrating operator is also ALT, so D is the right option both. Okay. So thank you very much friend. Next lecture we will do the some more numerical problem based on linear transformation image. So thank you very much.